Right, so welcome to this class, okay, where we are going to be solving questions from Tutor Sheet 1. That's for second semester UNILUS campus, okay? So these questions are on trigonometry and radian measure. So in the previous class that we had, we solved question 1, okay? So we proved all these formulas here that you can find under radian measure, okay? And then in today's class, we want to use those formulas to answer questions now. Okay, so the first one, we are going to solve question 2 here. And then we are going on to solve question 3 and question 4. Okay, so that will be what we'll be doing today. So we'll solve these questions step by step. So if you have any questions concerning whatever I'll be explaining as I solve these questions, feel free to ask. Okay. Right, so we start with question 1 there. Okay, we start with question 1 there. So question 1 reads, a garden has sides BA with length 10 meters, BC with length 6 meters, CA with length 12 meters, and then they're saying a point D lies on AC such that BD is an arc of a circle center center A with radius 10 meters. Okay, the diagram is shown below. So in this diagram, let's label the sides that we've been given. First of all, we've been told that BA is 10 meters. So BA is from here up to there. So this here we've been told is 10 meters. Okay, and then we've also been told that BC is 6 meters. So from here up to there, we are told is what? 6 meters. All right, and then we will also be told that AC is 12 meters. So the distance from this C all the way up to A here, we've been told that it's what? 12 meters. All right, and then what other thing have we been taught? We've been told that this A here is the center, okay, of the circle. So the circle can go like that, and I mean, not like that. This is the center here. So it means you have a whole lot of circle around it like that. Okay. All right. So from the center, okay, to the end B here, we have that it's 10 meters. Okay. So this 10 meters, we're also being told that it's the radius of the circle. So we know that if I have a circle here, and then I have this point, okay, if I draw a line from the circle up to the edge of the circle, okay, from the center of a circle up to the edge of a circle, and then I also draw another line from the center up to the edge of the circle, okay? This length here and this length will be the same. They will both be the radius, okay? So the length of this part will be equal to the length of that part. So when I come now to this diagram here, okay, the length from A to B will be told it's 10, okay? And then I can see that from B to D there, I'm making an arc like that. Okay, so it means the distance from D all the way up to A here, it's what? 10 meters as well. Okay, because it's making a sector there. All right, and then we're going to say that, okay, we're going to say that since the distance from this D to this A is 10 meters, what is the distance of this part here, which is from C to D? Okay, so we've been told the total distance from here all the way up to there is 12, but we know that the distance from D all the way up to A is 10. Okay, so it means this distance here, CD, will just be what? 12 minus 10. Okay, that will be 12 minus 10. So we're going to say this distance here, CD, is just 2 meters. Okay, so once we get our sides now, we are ready to answer the following question. All right, so they're saying the first question, find the size of angle BAC. So angle BAC, okay, will be this angle here, B, A, and then C. So the letter that is in the middle here, okay, that's where this angle will be. The letter that will be in the middle there, that's where this angle will be. So it means this angle BAC will just be this angle here. So we can say this angle is what? Theta, like that. All right, so we want to find this angle. So what are we going to do in order to find that angle? okay, we are going to use what we call as the cosine rule. Okay, so what does the cosine rule state? So if I have, for example, this is my triangle, okay, so we know that the angles in the triangle are represented by capital letters. So let's say this is angle A, angle B, and then I have what? Angle C. Okay, so to the opposite side of angle A, we're going to have side A. To the opposite side of angle C, we're going to have side C. To the opposite side of angle B, we're going to have side B. Okay, so the cosine rule states that, okay, if I want to find the length of this side A here, it will just be A squared is equals to, and then I square this side B and this side what? C. So I'm going to say B squared plus C squared minus 2, and then I multiply B and C again, and then I'm going to say cos angle A. So we notice that from this formula here, okay, the side that you are finding here, okay, the side that you're finding here, you should put its angle at the end. So meaning if we are finding side B squared, okay, it will be A squared plus C squared minus 2AC, and then cos C, okay? I mean cos B there, not cos C. Yeah, so the angle that should be there should correspond to the side that you're finding here, okay? Meaning if we are finding C squared, it will just be A squared plus B squared minus 2AB, and then cos C. Okay, notice that the angle here should correspond to what we have here. Okay, so we're going to use this cosine rule here to find that angle BAC. Okay, so the angle BAC is the same as just saying angle A. Okay, so we want to find this angle here. So it means we have to use A. Okay, we have to use this formula here. Okay, we have to use that formula there. So we're going to say from that our triangle, okay, let's redraw it. Let's redraw it here. So from that our triangle, okay, let me draw it here. And then it goes like that, and then it goes like that. So I have A there, I have B here, and then I have C. So it means the opposite side here, from this angle A here, the opposite side would just be what? The length A. Okay, so the side is represented by a small letter. The opposite side of angle B there would just be what? Side B, which is being represented by a smaller letter B. Then the opposite to this C would just be C there, which will represent by a small letter what? C. So we want to find this angle here. Okay, so if we want to find this angle, okay, if we want to find this angle, it means we need to know this side, okay, and that side, and this side here. Okay, so we know all this. We can see that A from here is just 6. Our C will be equals to 10. And then our B will be equals to what? 12 meters. So we have everything that we need in order to find this angle here. So we are going to say A squared, okay, is equals to B squared plus C squared minus 2BC, and then cos, I almost wrote the sign, and then cos the angle A that we are looking for. So this angle A, remember I said angle BAC is the same as angle A. All right, so let's replace the numbers. So A is just 6 squared is equals to, this one here will be, what is our B? Our B will be 12 squared plus, our C is 10 squared minus 2, and then multiplied by B. So B is 12, C is 10, and then I'm going to say cos A. Okay, so from here, what are we going to have? Okay, from there, what are we going to have? So let's take whatever we have here on the other side. So we are going to have this side. We're going to have, what are we going to have this side? Okay, so 6 squared. All right, so let's take this part here to the right, and then take this 6 squared to the right. Okay, so let's take this 6 squared to the right, and then this part we take it to the left. So this will be 2 multiplied by 12 multiplied by 10. So 12 multiplied by 10 is going to give me what? It's going to give me, okay, let me write. So it will be 36 here is equals to 12 squared is 144 plus 10 squared is 100, then minus 2 multiplied by 12 multiplied by 10. So that would be like a 120, and then we are multiplying it by 2. Okay, or we can say 2 multiplied by 12 is 24, then 24 multiplied by 10, that would be 240. So I have 240 and then cos A. Okay, so let's erase the top part. Okay, so if we continue with our question, we are going to have 36 is equals to 144 plus 100. It's going to give me what? It's going to give me 244 minus 240, and then cos angle A. Okay, so let's take the 240 on the left-hand side. So it will be 240 cos A is equals to, and then here we are still remaining with the 244 minus 36. So that will be minus 36 like that. Okay, so from there now, we can divide both sides by 240. We are going to have cos A is equals to, okay, what is 244 minus 36? So 244 minus 36 is going to give me a 208, and then divided by 240. Okay, so we know that if we have such, and then we want to find the angle there, we're just going to take the inverse, right? So it will be angle A is equals to the cos inverse of 208 divided by 240. Right, and then you just punch that value now onto your calculator, okay? You should be able to get your angle. So now notice here that we are dealing with radian measure, okay? We're dealing with the radian measure. So if you're dealing with radian measure, make sure that your calculator, okay, is in radian mode, not in degree mode. Okay, so change your calculator to radian mode whenever you are solving questions on radian measure. Okay, so if I change my calculator to radian mode and then I do the inverse of 208 divided by 240, I'm getting 0.5233 rad, like that. Okay, so this here will be the answer for the angle A, or for the angle A, and for the angle BAC. Okay, so we can write that somewhere to just keep the answer. All right, so any questions there? Okay, any questions there, guys? Right, so I'll proceed if there are no questions. All right, so I'm going to write here what we found. So we found that angle BAC is actually equals to what? Okay, we say the 0.5233 rads, like that. Okay, so this is our angle. All right, so we've found question 1. Let's go to question 2. So question 2, they're saying the perimeter of the shape, find the perimeter of the shape BCD. So BCD, it is which shape? So it is starting at B here, and then we go to C, and then we go to D. So we notice that that shape is just this shape here. I'm going to write it here. And then we have like an arc like that, okay? So we have B here, and then we have C here, and then we have D. So we're asked to find the perimeter of this shape. So how do we find the perimeter? We add the length here plus the length here, which we found it was 2 meters, and then we have to add the length there. Okay, so this one here will just be our arc length. From this circle here, remember, from here I go like that, and then I also go like that, okay, to the center of the circle here. So it means this part here is just the what? Okay, let me trace it in yellow. This part here is just the arc length of this sector here. Okay, so how do we find the arc length of the sector? Okay, so arc length is equals to theta, r multiplied by theta. So r is the radius, and then theta is the angle, which is here, which we found as this. Okay, so the radius, remember, we're told it's 10 meters here. So we can find that arc length. So we are going to say this is equals to, the radius is 10 multiplied by the the angle, which is in radians, 0.5233. Okay, so when I multiply that, what am I going to get as my arc length? Okay, so I'm going to get, let me multiply on my calculator. So be counter checking with yours too. So 10 multiplied by, okay, 10 multiplied by 0.5233. I'm going to get 5.233, okay, meters. So it means we now have the length of this L here, which is just 5.233. So it means we can find the perimeter of that shape. So we're going to say perimeter, okay? Perimeter is just the total distance around the object, right? So perimeter of BCD will actually be equals to 6 plus 2 plus the arc length, which is 5.2. Okay, my space there has finished. It's fading to right side. So I'm going to write it here. So 6 plus 2 is 8. Okay, 6 plus 2 is 8. So I'm going to write 8 plus 5.233. So it means our perimeter will just be what? That number plus 8. So it's giving me 13.233 meters. Okay, so that's how we find the perimeter there. So any questions before we move to the next one? All right, no question. I'll move to the third one where we're now finding the area. Okay, so let's remember our angle there, BAC, was just given by 0.5233 rads. Okay, so now here we are asked to find the area of the shape. Okay, the area of the shape BCD. Okay, so where is the BCD there? Okay, where is the BCD? So the BCD is this shape here, BCD. So the same shape for which we calculated the perimeter. We're now calculating the area. So this is the shape here, and then it comes like that. Okay, so we have B and then C and then D there. So we want to calculate the area of this part here. Okay, so how can we calculate the area of that part? Okay, so remember when I go this side, okay, and then I also go that side, I'm forming a triangle, okay? So I've drawn it in a bent way. Let me put it a bit straight. Like that. Okay, so if I complete this diagram like that, okay, we see that this part here, the one I've traced in yellow, is just the sector of a circle. Okay, so we said the area of a sector is just 1/2 r squared multiplied by theta. So we're going to use that to find the area of this part. Okay, and then this whole thing, okay, this whole thing here, BCD, it is forming a right angled, it's forming a triangle there, not necessarily right angled, but it's forming a triangle there. When you move from B to C and then to A there, okay, we see that it's forming a triangle. And then from the first lesson, we said we derived the formula, okay, of the triangle to be, okay, half, and then we multiply by the A, multiply by the B, okay, and then we say sine theta. Okay, so to find the area of this red part here, we are just going to say the area, okay, of the shape BCD is equals to the area of the triangle, which is half AB, okay, and then sine theta minus half r squared theta. Okay, so we're just going to subtract the area of this whole triangle here, and then we subtract this yellow part here. Okay, so if we remove this yellow part, we're going to remain with the area of this part here, right? Okay, so if you have any questions, feel free to ask. So we are going to use this formula here in order to calculate the area of this part where I've put to my blue dots here. All right, so let's calculate. All right, so All right, so let me rewrite the formulas. So I'm going to say the area of BCD is just equals to the area of the triangle. Okay, so the area of the triangle is half AB sine theta minus the area of the sector, which is r squared theta. So half. So what is our A and what is our B? Okay, what is our A and what is our B? Okay, so our B and our A are just these opposite side here. So we say that since we are using angle A here, okay, we say this is A, this is B, and then this is C. Okay, so actually here I'm supposed to put B and C, not A and B. That wouldn't be correct because we are using angle A. So we are going to say the area is equals to B multiplied by C and then sine the angle which is at A. So sine angle A, like that. Okay, so we have this side multiplying by this side, and then we are getting the sine of the angle that we have there. Okay, so I'm going to multiply 12 multiplied by 10. Okay, so we can see that this side here was 10, that other one was 12. So I can multiply like that and then sine the angle. Okay, so the angle that we found in radians was just 0.52 and then 33. And then we're going to say minus 1/2 of r squared. R squared, what was our r? Our r is our radius. We've been told here that it's 10. So we're going to say 10 squared, okay, and then multiplied by the angle here, which is in radians, so 0.5232, like that. Okay, is it 33? It is 33 here. So let's calculate the area. Okay, so let's just punch all these numbers into our calculator. Okay, so if I punch 1 divided by 2 multiplied by 10 multiplied by 12 multiplied by sine 0.5233. Okay, and then I put that in brackets, and then I say minus, open bracket, I put 1/2 10 squared 0.5233, and then I close the bracket. Okay, so my area is approximately giving me 3 point, I'll round it off to 3 significant figures. Okay, 3.82 meters squared. Okay, because it's the area here. All right, so this is the area of the part which is the body BCD. All right, so any questions? Right, no questions. Let's move to the next question then. Okay, so the next question is also on radian measure. Okay, so we have to read the question and then we picture it so that we can solve it. Okay, so the question reads, a circle, okay, a circle has center O and radius 9 centimeters. The points A and B lie on the circumference of a circle. The minor sector or AB has a perimeter of 30 centimeters, and the angle between the LAD OA and OB in this sector is just it's just theta radians. Okay, find the length of the arc AB. So let's picture what we have. So we have this circle here. Okay, we have been told that we have this circle which has a center O. Okay, and then from this center O, we have a radius of 9 meters going to the edge of the circle like that. So this is the radius equaling 9 centimeters. Okay, we also have another radius going to the edge. It will still be 9 centimeters. Okay, and then we are told that the points where this radius, okay, touches the circumference of the circle are just what? A and B. Okay, so these are the points that lie on the circumference of a circle. Okay, so what else have we been told? We've been told that the perimeter, okay, of this sector, okay, O, A, and then B, it is just 30 centimeters. Okay, so perimeter, it means we are adding the distance around that shape. Okay, so this is the shape that we have, like that. So it means we're adding 9 here, 9 plus this arc length here. Okay, let's represent it by L. So that arc length there will be not R, but L. Okay, so this will be the arc length. So they mean that when we add 9 plus this L, we're getting 30. That's what it means to be having a perimeter. So perimeter of OAB is equals to the radius plus the arc length. So the perimeter we've been told that is 30. The radius, we know that it's 9 plus 9 and then plus the arc length. So we can use this formula to find the arc length AB, okay? Because this is the arc length AB here. We can represent it by L. So we're going to say 30, okay, minus, what is 9 plus 9? 9 plus 9 is 18, and then is equals to the arc length L. So it will be 30 minus 18. So it means the arc length will just be what? The arc length will just be 30 minus 18, which is 12 centimeters. Okay, so we've calculated the arc length AB here, which will just be 12 centimeters. All right, we can now go to the next.
Excuse me, sir. I don't know if it's just me, but I can't hear what you're saying. If you're saying,
Hello? Can you get me now? Kindly confirm if you can get me now. Can you get me?
oh yes, I can hear you now.
Don't know. So from which point were you not getting me?
From the second question,
Ah,
I don't even know where we are, but the second question,
the second question right here on this screen.
yes.
Okay, so okay, so it means I'll just share the recorded video so you can watch that part that you missed. Okay, I apologize for that. I don't know what happened to my mic, but someone was asking what's the difference between a segment and a sector? So this is what I'm trying to explain here. So I was saying if I have a circle there and then I have the center there, okay, a line that comes from one edge of the circle to the other edge of a circle like that, and it passes through this center here. It's called the diameter, okay? And then if I have any other line that comes from one edge of the circle to the edge of to the other edge of the circle, okay, but it's not passing through the circle here, I mean the center there, we call that line a chord or a chord. So that chord, okay, that chord will divide the circle into what we call as the segment. Okay, so I have this segment here, which I was shading in yellow. Okay, so this part I've shaded in yellow will be the minor segment because it's small, as you can see. And then that part I'm shading in white here, okay, will be the what? The major segment. So it is a chord that makes the segment. Okay, so you can't confuse segments with a sector. Okay, on the other hand, if we now talk about the sector, okay, it will be a line that comes from the center going to one edge of the circle like that. And then we also have another line coming from the center going to one edge of the circle like that. So this part here, okay, where I'm tracing with the yellow marker here, this part here, okay, it is a sector. So a sector will be in this form, something like that. But the segment, okay, will just be like this and then like that. So this can be the minor segment, and then the rest of the part here will be the major segment. So don't confuse those two, okay? All right, so that's it on this question. And then let's look at another question now, which is question 3. So on question 3 here, we have some trigonometric functions that we need to evaluate. Okay, so we are evaluating these trigonometric ratios, remind you, without using a calculator. Okay, so it means you have to know your trigonometry like that. So it means you have to know the spatial angles, okay? You have to know the 30, the 45, okay, the 90, those are spatial angles. So you have to know sine 90, what is sine 90, sine 30, sine 45, cos 30, cos 35, tan 30, tan, just like that, okay? So here, the first one here, we have A, okay, and then cos C, and then we have sine inverse of 3/5. So how can we evaluate this? Okay, how can we solve this without using any calculator at all? We are going to say, okay, let what is in the bracket here equal to this symbol here. Okay, we're going to say let whatever is in the bracket equal to this symbol here, and then like that. Okay, so I know if I have let me just write this symbol as a theta, right? Okay, so that we can be mentioning it. So let's say theta is equals to the inverse of sine of 3/5. So I know that this here can change into what? Sine theta is equals to 3/5, right? We know. Okay, if you don't understand, please ask. So this is what we get from that expression on top there. So from this, okay, we are going to go on the we're going to go on we're going to draw a right angle triangle, okay, and then check the side that have been represented here. Remember, we said whatever is inside here is equals to theta, right? So it means here I can write cos theta, okay, where this theta is representing whatever I have here. So what is cos theta? Okay, so we're going to say that, let's say I have this right angle triangle. Okay, so when you're dealing with trigonometry, then the triangles are right angled. So this is 90, okay, and then let's say this is my angle theta. So where it's facing here, you have your opposite, and then this side you're going to have your hypotenuse, and then the side that has both the angles, the right angle triangle and the angle there, we call it as the adjacent. Okay, so from your SOHCAHTOA, if you remember from high school, okay, SOHCAHTOA, from this SOHCAHTOA here, we know that sine, okay, a certain angle, let's say theta, is just equals to opposite divided by what? Hypotenuse. And then cos theta is just equals to adjacent divided by what? Hypotenuse. All right, so from this expression here that I have, okay, it means that sine theta is equals to 3/5. So if sine theta is equals to 3/5, it means this 3 here is the opposite, and then this 5 here is the what? The hypotenuse. So we can actually replace those sides into this right angle triangle. So we're going to say the opposite is 3, and then the hypotenuse is what? Is 5. All right, so what about now, how can we find the length of this adjacent here? Okay, we are going to use the Pythagoras theorem. Okay, so we know what the Pythagoras theorem states. Okay, it states that the hypotenuse squared is equals to, okay, the opposite squared plus the adjacent what? Squared. So we know that, okay, we know that. So we are going to say the hypotenuse we have, it is 5 squared is equals to, the opposite we have, it is 3 squared, and then plus the adjacent that we don't know squared. So it means the adjacent squared will just be equals to 5 squared is 25, and then minus this 3 squared is 9, and then we take it to the other side to be minus 9. So it means we are going to have what? 16. So we have a squared, which is adjacent, being equal to 16. So we can find the value of what? The adjacent there. Okay, so we take the square root of both sides. We are going to find that the adjacent is just equals to what? 4. So we're going to put 4 as the adjacent there. Okay, so remember, we're just finding cos theta there. Okay, remember, we're just finding cos theta there. So if I'm finding cos theta here, okay, and I have the theta there, okay, so if I'm finding cos of this theta, it will just be this formula here, to be adjacent divided by hypotenuse. Okay, so I'm going to write cos theta is equals to adjacent, that we are from finding, which is 4, divided by what? Hypotenuse. And then remember our assumption, we said let theta be equals to whatever was inside, which is a sine inverse of 3/5. So we're going to replace back, okay, this theta, we're going to replace back this guy here. So we're going to say cos, and then we have sine inverse of 3 divided by what? 5, like that. So this here is going to equal to 4/5. So we found the value of this guy here without even using the what? The calculator. So any questions there before we move on? Any questions? Okay, no questions. I'll proceed. All right, so let's solve B now. Okay, so on B, we'll be required to know some special angles. Okay, B, because there we're just evaluating a trigonometric ratio. So there's no need for some special angles. But here on B, we need to know some special angles. So here we have cos inverse of root 3 multiplied by tan pi over 6. Okay, so what we can see here is that we have a special angle. Okay, so I don't know if you've learned how to convert from rads to degrees. Okay, so we said pi rad is the same as 180 degrees. Okay, so what about pi over 6 rad? It will be equals to x. So cross multiply, you're going to get x pi is equals to 180 multiplied by pi divided by 6. So if I divide this 180 by this 6, I'm going to get what? I'm going to get x pi is equals to 30 pi. Then divide both sides by pi, you're going to get your x is equals to 30 degrees. Okay, so this 30 degrees in radians, it is the same as pi over 6. So we know that 30 degrees here is a special angle. Okay, we know that 30 degrees is a special angle. So it means in the brackets there now we have, okay, we can say we have cos inverse of root of 3 and then tan. Okay, we can even replace this with a 30 degrees just for simplicity. Okay, so what is tan 30? Okay, so that's the importance of knowing the special angles. What is tan 30? Okay, so tan 30 is equals to, I'll write it on top here. Tan 30 is equals to 1 over the root of 3. So some people, they say tan 30 is just equals to the root of 3 divided by 3. So this here and this here, they're just the same. So this one that I have down here is when you rationalize the denominator. So you multiply by root of 3 on top and down. You're going to end up with the root of 3 over 3. Okay, but as we're going to pick this first one, which is 1 over root of 3, so that that root of 3 can cancel out with this root of 3. So what we have here will be equals to cos inverse of root of 3 multiplied by this tan 30 here, we're saying it's 1 divided by what? Root of 3. So it means here now, the root of 3 and this root of 3 is going to what? To cancel. So we're going to remain with cos inverse, okay, of 1. Right, so what is the cos inverse of 1? Okay, cos inverse of 1 is 0. Okay, so cos inverse of 1 is 0. So 0 will be the first answer. So cos inverse of 1 is just 0. Remember, we are taking the angles in rad here. So we're going to say 0 rad. Okay, so this 0 here will be in the first quadrant. So remember, we have 4 quadrants, right? So whenever you're finding the angles for a certain inverse of a trigonometric ratio, there is at least, okay, 2 angles for that. So we know that we have these 4 quadrants, and then in this first quadrant, all the trigonometric ratios are positive. So all students take coke. So in this first quadrant, the sine, okay, the cos and the tan, they are all at positive. But here where I just have S, it means only the sign is positive in here. Okay, what about in here where I have T? It means only the tan is positive. The cos and the sine will be negative here. And then here where I have the C, it means only the cos is positive. And then the tan and the sine will be what? Negative. All right, so when you find an angle, okay, from the inverse of a trigonometric ratio, there is at least 2 answers. Okay, so the first one we found is 0 rad. So how can we find the other answer? Okay, so you take a look at the number that you have here in the bracket. So if it is positive, then it means we are considering the quadrants where this cosine is positive. So the quadrant where this cosine is positive, the first one is in this first quadrant here. And we can see that we have 0 rad in that first quadrant. Okay, so here I have 0 rad, and then I go to pi over 2 rad, which is 90. And then I go to pi rad, and then here it will be 3 pi over 2 rad, which is the same as 270. And then I go back to here, I'll have 2 pi like that. Okay, so if I want to find the second angle in the fourth quadrant where I have the cosine there, okay, I'm going to say that angle will just be equals to 360. Okay, but now here we are dealing with rads, so we can't write 360. We're going to write 2 pi minus the angle from the first quadrant. So the angle from the first quadrant, we found it was 0. So it means the other angle there will just be what? 2 pi. So it means our answers to this question will be 2. Okay. The first one, it will be 0 rad. And then the other one, it will be what? 2 pi. So we're going to say cos inverse of 1 is equals to, we had 0 rad. Okay. And then we say, or cos inverse of 1. Here now we have 2 pi rad. All right, so any questions there? Well, now we are solving these things. Any questions there? All right, no question. Let's go to C then. Okay, so C, we have this question here. We have that cot, okay? We just know that cot is just 1 over tan, okay? We have cot of sine inverse of 2 divided by 3 like that. So this here, we're going to solve it in a similar way. We solved question A. We're going to say let theta, okay, let theta be equals to sine inverse of 2 divided by 3. So we know that this sine inverse, okay, it can turn into sine theta is equals to what? 2 over 3. And then we can drop a right angle triangle like that. Okay, so we can put our theta there. And then here 90 degrees. Okay, so we know that theta is opposite over adjacent. So the opposite here will be 2. The adjacent will be what? 3. So we need to find the value of the adjacent here. So here I meant the hypotenuse, not the adjacent. So we need to find the value of this adjacent that I've put a yellow line there. So how do we do that? We go to the Pythagoras theorem. Okay, so 3 squared is equals to 2 squared plus adjacent squared. So this will be 9 minus 4 is equals to adjacent squared. So it means adjacent will just be equals to 4. 9 minus 4, it's 5. And then we take the square root of both sides. So it means the adjacent there will just be the root of what? 5. All right. So now we want to find the cot angle. Okay, so cot theta, well, theta is this guy here. So cot theta there will be equals to what? So we are first going to change this into a tan. So we know that cot is the reciprocal of a tan. So it's 1 divided by tan theta. Okay, so from your SOHCAHTOA, okay, okay, from your SOHCAHTOA there, okay, when we reach on the tan, okay, is simply, tan theta is simply equals to opposite divided by what? The adjacent. Okay, so we have the opposite and the adjacent in order to find this tan theta. So this theta is this angle. Okay, so our opposite will be 2, our adjacent will be what? Root of 5. So we're going to say this is the same as equals to 1 divided by, this tan theta here will be, okay, opposite, which is 2, divided by the adjacent, which is the root of what? 5. And then we're dividing by 1. So this, it means it's going to be root of 5 divided by 2. So cot theta will just be equals to root of 5 divided by 2. And then we can put back the value for the theta there. So we're going to say cot of sine inverse of 2 divided by 3 is actually equals to, what do we have there? It's actually equals to root of 5 divided by 2. Okay, so that's the answer there. So any questions there? All right, no question. Let's proceed to the last question for today. Okay, so the last question for today is this one here. So we are going to simplify this using what we call as the double angle formulas. Okay, we're going to use the double angle formulas. All right, so just a minute. Okay. All right, so the double angle formulas, okay, they state the following. So I'm going to write 3 of them. One will be for the cos, the other one will be for the sine, the other one will be for the tan, okay? So we're going to use those double angle formulas to prove whatever we have here. So the first one is the sine. So if I have sine of 2 angles, maybe angle A plus angle B, okay? So this here will be the same as sine angle A cos angle B, and then plus cos A, and then sine what? B. Okay, so it means that if I have maybe the difference of 2 angles, so let's say sine sine A minus B, okay, sine A minus B, it will just be the same thing, but with a minus in between there. So it will be sine A cos B minus cos A sine what? B. So we're going to use this to prove the first question there where I have a sine. And then what about the double formula for the cosine? So cosine of A plus B is actually equals to cos, okay? It's actually equals to cos A, okay? And then I have cos A cos B, okay? And then minus sine A sine B. Okay, so that's the double angle formula for the cos. Okay. What about the double angle formula for the tan? Okay, so for the tan, we're going to have the following. Okay, so I think I've mixed up the angles on the cos. Okay, the angles should be the same here. So this cos A should be cos A, and then okay, let me see. All right, so I was saying what? I was saying, okay, it's just fine. It's just fine. I thought I mixed them up. So if you have cos A plus B, it will be cos A, cos B, and then minus sine A, sine B. Okay, so that will be the angle that the double angle formula that we'll be using for a cos, and then we can also have the one in terms of a minus. So it will be sine A minus B. This will be the same as cos A cos B, and then we say plus sine A, and then sine what? B. Okay, so notice that if we have a plus here, it means in the formula we're going to have a minus. If I have a minus here, it means in the formula I'm going to have a what? A plus. So that's how, that's the double angle formula for a sine. Okay, that's the double angle formula for a sine. And then let's write the one for the tan. So the one for the tan will be in this form. Okay, we are going to say tan okay, we're going to say tan A plus B is equals to tan A minus tan B, and then divided by, okay, divided by, oh, here I have a plus, so here I should have a plus when you're dealing with the tan. So tan A plus B will be tan A plus tan B, and then in the denominator, I'm going to have 1 minus tan A tan B. Okay, so if I have a plus here, it means in the numerator there, I'm going to have a plus again, but in the denominator, I'm going to have a minus. So if For example, I have tan A minus B, okay? This here will be the same as tan A, okay? Because we have a minus here, I'm going to say minus tan B, and then I'm going to divide all this by 1, okay, plus tan A, and then tan what? B. Okay, tan B like that. So notice the difference when we have different signs, right? Okay, so this is the double angle for the tan. Okay, so now let's solve the first question. Okay, so we are going to be using special angles here in order to solve these questions here. So the first one is show, okay, that sine 45 degrees is equals to root of 6 plus root of 2 divided by 4. So we're going to say sine 75 here is equals to, so we're going to look for two angles such that when we add them, they give us 75. So that would be sine, okay? I'm going to have what angles can I get? I'm going to have 45, okay, because it's a special angle, plus 30. So make sure that the angles that you get here to represent this one angle should be special angles, okay? So this will be the same as sine 45 plus 30. And then we can expand it using the double angle formula for the sine. Okay, so this is going to be sine 45 cos 30 plus cos 45 sine 30. Okay, so what is cos 45? What is cos 30? What is cos 45? Okay, so sine 45 as a special angle, okay, it's just the root of 2 divided by 2, okay, and then we are multiplying this with a sine 30. So sine 30 is what? Sine 30 is the root of 3 divided by 2, and then I'm going to say plus, what is cos 45? So cos 45 and sine 45 are actually equal. So it will just be the root of 2 divided by 2 multiplied by, what is sine 30? Sine 30 is half. Okay, so let's multiply. So from the laws of SADs that we learned in first semester, we knew that if I have the root of A multiplied by the root of B, this is the same as the root of A multiplied by B, right? So this here on top, I'm going to multiply them. It's just going to be the root of 2 multiplied by 3 is going to be 6. And then I'm dividing this by 2 multiplied by 2, which is what? 4. Then I'm going to say plus. On the other part, it will be root of 2 multiplied by 1, which is just root of 2, divided by 2 multiplied by 2, it will be 4 like that. Okay, and then from there, we see that we have the common denominator. So we can add the, whatever is on top there. So it means the common denominator there will just be 4. And then we add root of 6 plus the root of 2. So we see that this here is what we have in the question there. All right, so that's how we can prove that sine 45 degrees is equals to the root of 6 plus root of 2 divided by 4. All right, so any questions there before we solve B? All right, so let's solve B now. So let's prove the B. Okay, let's prove the B. So B, we have cos 75 degrees. Okay, so this we are going to say is the same as cos 45 plus 30. Okay, so this here is going to be equals to what? It's going to be equals to cos 45 cos 30, and then minus, I'll have sine 45 and then sine 30. Okay, so what do I get from there? So I know that cos 45 is just the root of 2 divided by 2 multiplied by cos 30 is the root of 3 divided by 2 minus sine 45 is the root of 2 divided by 2 multiplied by sine 30, which is 1 divided by 2. So this here is going to be equals to the root of 6 divided by 4 minus root of 2 divided by 4. So we have the common denominator there. It means our answer will just be 4. And then we have the root of 6 minus the root of 2 there. So we have proved, okay, that cos 45 degrees is just the root of 6 minus the root of 2 divided by what? 4. All right, so let's do C now. So on C, what do we have? So on C, we have tan 15 degrees. Okay, so that 15, we're going to separate it into angles, into 2 angles, such as those 2 angles are special angles. So this will be the same as tan, okay, 45 minus 30. We know that 45 minus 30 to be 15, right? All right. So, and then from there, we now apply the double angle formula for the what? For the tan. So this is going to be equals to tan 45 minus tan 30. And then we're dividing all this by 1 minus tan 45 multiplied by tan 30. So this is what we have here. So we're going to say this is equals to, okay, what is tan 45? Okay, what is tan 45? So tan 45 is 1. Then minus tan 30 is 1 over root of 3. And then we are dividing all this, okay, we are dividing all this by, okay, we're going to say divided by 1 minus, okay, so here I'm supposed to put plus, right, in the formula. So I forgot, this is plus. So if you have a minus on top, this should be plus. So down there, we're going to have 1 plus, okay, and then 45, which is 1, multiplied by tan 30, which is 1 over what? 3. So I'm going to have 1 over the root of 3 there. Okay, and then from there, what are we going to get? Okay, so from there, we can simplify. Okay, we can simplify from there. So we're going to say, let's rationalize the denominator for this guy and this guy. So if we rationalize the denominator there, what are we going to get? Okay, or maybe we can first solve, so we can solve it. We can solve it. Okay, so let's say we have 1 minus 1 over root of 3. So the 1 will be over 1, and then this will be the common denominator of the root of 3. So 1 into root of 3 to be root of 3 minus, then root of 3 into root of 3 is 1. So 1 multiplied by 1 to just be 1. So from the upper part there, the numerator, I'm getting root of 3 minus 1, and then divided by what? Root of 3. Then I'm going to say this divided by, and then in the numerator there, I'm adding 1 plus 1 over root of 3. So it means here, I'm just going to change the sign like that. Okay, so it means I'm going to have root of 3 plus 1 divided by root of 3. And then from here, we know that this division sign changes into a multiplication sign, right? So we're going to have root of 3 minus 1 divided by root of 3 multiplied by the root of 3 divided by root of 3 plus 1. So this is what we have. So from there, we see that the root of 3 and the root of 3 will cancel. Okay, so meaning the expression that we now have will be this. Okay, the expression that we now have will be equals to, we have 3, root 3 minus 1, root of 3 minus 1, and then root of 3 plus 1. So what can we do to this to make it appear in this form here? Okay, we try to rationalize the denominator. Okay, so rationalizing the denominator, we are going to multiply by the conjugate, okay, of what I can see in the denominator there. Okay, so what's the conjugate of this? It's just the root of 3 minus 1. Even here, multiply by the root of 3 minus 1. So the upper part there, okay, is going to be root of 3 multiplied by root of 3. It's going to be 3. And then what else do I have? Root of 3 multiplied by minus 1, it will be minus root of 3. And then 1 multiplied by minus root of 3. What am I going to get? I'm going to get minus root of 3. And then minus 1 multiplied by minus 1, I'm going to get plus 1. Okay, and then this divided by, so here now we have 2 conjugates. Okay, we have 2 conjugates of each other. So from there, it means we are going to have what? Okay, we're just going to have the first part, you square it, and then you say minus the second part, you also square it. Okay, so that's how you expand 2 expressions that are conjugates of each other. You just get the first one here, the root of 3, you square it, and then say minus it. You get the second part, which is 1, you square it. So from here, I'm going to have equals to 3 plus 1, it will be 4. And then minus root of 3 minus root of 3 is going to be minus 2. Okay, it's going to be minus 2 root of 3. Then this divided by, here, if I square the root of 3, I'm just going to get 3. And then minus, what is 1 squared? 1 squared is 1. So this will be 3 minus 1, which will just be 2. So let's divide this 4 and this 2 by 2. I'm going to get 2 minus root of 3. So we see that tan 45 degrees, okay, is indeed 2 minus root of 3. All right, so any questions on what we've done so far? Okay, any questions there, guys? Any questions? All right, so if there are no questions, I'm going to leave this D here for you guys. Okay, you can try it out as your practice question. Okay, so just use the same principles that we are using on all these other questions. Okay, and then try to solve this one here. All right, so that's where our class ends today. So any questions, you are welcome to ask me. Any questions? All right, so if there are no questions, then have a blessed night.